Imagine a world where, really cutting edge medical insights are just there,
Mhm.
available, not just for a few people, but for anyone, anywhere, maybe right on your phone or laptop.
Yeah, sounds a bit like science fiction, doesn't it?
It does, but it's actually the vision behind this new wave of open source AI we're seeing.
Hmm.
So today we're going to take a deep dive into what intelligent internet has been up to lately. We've got their recent blog posts, some white paper
We're
details.
focusing on their whole philosophy around open source AI,
Yeah.
and especially these AI medical models they've put out.
Exactly. And our mission really is to unpack how these things are built, what makes them tick, what they can do, what they can't do.
And what it all means for you, whether you're just curious, maybe a healthcare pro, or just interested in where tech and health are heading.
Okay, let's get into it. So first off, intelligent internet's whole philosophy really sets the stage here. You remember Emad Mustak, the founder, talking about
Mm.
stable diffusion almost 3 years back?
Oh yeah, the generative AI for images. Big
Yeah.
splash.
Huge. And he said something like, they were about to change the world by raising the ability of anyone, anywhere to create, because all of us have that ability. That core idea seems to drive them.
It absolutely does.
Yeah.
And, a key takeaway is that this thinking goes way beyond just making cool pictures. It connects to this bigger idea Imad Mustak calls the great decoupling.
The great decoupling. Tell me more.
Well, in their master plan article, he talks about this worry that intelligence, AI intelligence, could end up centralized, stuck in these opaque sort of godlike models.
And we just rent access, like a subscription to our own agency.
That's exactly the phrase he used.
Mm.
Agency is rented back to us as a subscription service. And he doesn't just see it as a tech problem. He calls it a moral problem.
Wow. Okay. Strong words.
Yeah. And he says it demands a new social contract built on new code.
Yeah.
So this open source push, it's framed as their answer to that potential centralization of power. It's about decentralizing.
That's a really powerful vision. And it's interesting to see how that translates into actual projects. Like they just had Commons Week, right? Launching wave 2 of their Thai Commons open source stuff.
Hmm. And a big piece of that was Common Ground.
What's that exactly?
It's their framework for multi-agent collaboration. But the idea, as they put it, is moving beyond code drops. It's about sharing their core thinking on human-AI partnership, building these things they call contexts together out in the open.
Okay, so building together, sharing the thinking. How does that whole spirit then apply to something as, well, sensitive and complex as medical AI?
Well, it applies directly, but with some major caveats. You see, medical AI isn't like general AI. It has these really unique challenges.
Like what?
Well, think about it. You need structured step-by-step reasoning. You need accuracy that's grounded in actual clinical knowledge, not just, statistically plausible text.
Right. And doctors need to be able to check its work, I guess, audit it.
Exactly. Outputs that can be audited by experts, that's crucial.
Yeah.
It's fundamentally about building trust for things that could impact someone's health. It's a much higher bar.
Makes sense.
So they've highlighted a few key methods they're using. Things like test time scaling to improve performance during use, supervised fine-tuning SFT learning from curated examples,
Okay.
reinforcement learning, RL, where it learns by trial and error, knowledge graph integration for structured facts, and even these self-evolution frameworks where models can potentially improve themselves.
We've seen some of those ideas in other medical models too, right? Like Lectro GPT-01.
Yeah, exactly. And MedReason 8B. They often use specialized data sets too, like MedQA and PubMedQA, to really focus the training.
Okay, so the stakes are definitely higher in medicine, which brings us to Intelligent Internet's first big move here, II Medical 8B, released back in May 2025.
Right, the 8 billion parameter model.
And what really jumped out was its size. They claimed it outperformed systems over 10 times larger on key clinical reasoning tests. It's pretty bold.
It is bold. And they designed it specifically for precision, transparency, and real-world applicability.
So given what you just said about needing robust, auditable decisions,
Hmm.
how significant is it that they started with a smaller, seemingly more efficient model that still claims that kind of performance?
Oh, it's incredibly significant because it tackles that accessibility problem head on.
How so?
When they talk about efficiency at zero cost and the fact that this II Medical 8B can apparently run locally on like consumer hardware.
Right, on your own machine, not in the cloud somewhere.
Exactly. They're basically saying you could have doctor-level medical reasoning directly in your pocket,
Wow.
which, opens up this fast, private, and affordable path forward. It's a massive step towards getting this kind of knowledge out there globally.
Bet. There's always a but, isn't there?
There's a very important but, and they're explicit about it. The disclaimer says iMedical is not intended for clinical use at this moment in time.
Okay, crucial point.
Absolutely. It's for research and development purposes only. So it's a tool for researchers, for developers to explore and build with, not something you'd use to diagnose patients today.
That disclaimer is vital, definitely grounds the hype a bit. Okay, so that was May 2025. Fast forward to July 2025, and we get the latest update. They announced iMedical 8B 1706 and a new, bigger one, iMedical 32B Preview.
All right, 2 new versions.
And they're talking major upgrades across the board, claiming it's the best open source model under 32B for multi-turn medical dialogues and precise compliance. What do these upgrades really mean in practice, and why 2 sizes now?
Well, the 2 sizes seem aimed at different users, basically.
Yeah.
The 8B 1706, the smaller one, is positioned for lightweight, safety-optimized local deployment. So think easier to run, more accessible.
Okay.
Then the 32B Preview, the larger one, is for power users and research applications requiring more depth and nuance, maybe needing more complex reasoning.
Got it. And how do they stack up performance-wise?
So this is really fascinating. The benchmarks show the 32B Preview, the bigger one, does grab the top spot. But the 8B 1706, the smaller one, trails by under a percentage point.
Seriously, under 1%.
Yeah. They say it delivers about 95% of the performance with only a quarter of the model size.
Wow, okay, that is interesting. So you get almost the same power in a much smaller package. That really pushes the accessibility angle again.
It does. And they also stressed other improvements, like reinforced safety from adding a third RL training phase, and better real-world clinical reasoning. Not just passing tests, but giving meaningful, explainable support.
Okay, let's unpack how they did that. The method section in their release details this 3-stage training pipeline. Can you walk us through that?
Sure. So stage 1 is supervised fine-tuning, or SFT.
Yeah.
The goal here is basically to pump up the model's knowledge, specifically in medical and healthcare topics.
Right, teach it the basics.
Kind of.
Yeah.
And they learned something from their previous AB model. It had a low IHEVAL metric.
IHEVAL, what's that?
It measures how well the model follows complex instructions. A low score meant it wasn't great at following detailed directions, sort of diminished instruction following abilities.
Ah, okay. Not ideal for medical advice.
Definitely not. So to fix that, they mixed in a data set specifically designed for multi-turn conversations and following instructions directly into this first SFT stage.
Smart. Okay, that's stage 1. What's stage 2?
Stage 2 is reinforcement learning, RL. This is used to further enhance the model's reasoning capabilities, making it better at thinking things through step by step.
And then stage 3. This one's new, right? Reinforced safety.
Exactly. This was added specifically because of feedback from the community about the safety and usefulness of the earlier models.
So people had concerns.
It sounds like it, or at least wanted more focus there. So this third RL stage is laser-focused on generating answers that are detailed, safety-first, and healthcare-focused.
How do they actually do that? Train it for safety.
It's pretty clever, actually. They set up a reward system for the RL training. It evaluated the AI's answers based on both accuracy and safety.
And who decided what was safe and accurate?
Get this. They used OpenAI's GPT-4o model as the judge during this training phase.
Wow, okay. Using one AI to train another on safety.
Yeah, and the model got the maximum reward only when its answer perfectly matched the ground truth, the correct example in terms of both safety and factual accuracy.
And they give examples of how this changed the output, right?
They did. Really compelling ones. Like a question about oxycodone use during pregnancy. The original answer was short, maybe too concise.
And the improved one?
The improved one explicitly stated, father's oxycodone use will not affect the fetus or cause birth defects, and even included helpful prep tips. Much more reassuring and clear.
That's a big difference.
Huge. Same with the Girard example. The improved answer had more consistent detail and safety warnings.
Yeah.
Shows the training worked.
Did they notice anything else about the safety training?
Yeah, an interesting side effect. Higher model rewards correlate with longer response lengths. The answers got more detailed. They mentioned the average response length increased significantly for both the 8B and 32B models after this stage. Around 500 tokens more for the 8B and 300 more for the 32B.
So safer often meant more comprehensive, which makes sense.
Exactly. And it wasn't just about rewarding good answers. They also built in constraints. They used something called a grader template during development.
A template for grading?
Sort of. It outlined this detailed A to E rating scale looking at safety, accuracy, and helpfulness. But critically, it included a specific instruction for the AI judge.
Telling it what not to reward.
Precisely. It told the AI judge to make sure the model being trained should avoid making definitive diagnoses, promising cures, or acting as a replacement for a qualified healthcare professional.
That seems really important. Building the ethical guardrails right into the training process. What does that signify to you, seeing that level of transparency?
It signifies, I think, a really crucial awareness of the risks. They understand that AI in healthcare isn't just about being smart. It has to be responsible and safe. It shows they're thinking hard about the potential downsides.
Right.
And this focus extends to the data they used. The main data set was their own AI medical reasoning data set, over 581,000 samples. Big data set.
Where do they get all that data?
A mix. Public reasoning data sets, synthetic meaning AI-generated medical Q&A, and carefully curated reasoning traces. But they didn't just dump it all in.
No.
No, they had this meticulous process to ensure it was all relevant to medicine. They used techniques like embedding generation, clustering, and domain classification to filter and categorize everything.
Making sure it was actually useful medical data.
Exactly. And importantly, they also used a two-step decontamination approach.
Decontamination, like cleaning.
Sort of. It's to prevent data leakage, making sure the questions used for testing the model weren't accidentally included in the training data. That's vital to make sure your benchmark results are actually reliable and the model hasn't just memorized the answers.
Okay, meticulous data handling, multiple training stages. Anything else special about the training? You mentioned reinforcement learning.
Yeah, for the RL stages, particularly stage 2 for reasoning and the stage 3 for safety, they used a specific algorithm called DAPO.
DAPO, what's that stand for?
Decoupled Clip and Dynamic Sampling Policy Optimization.
Oh, okay. Sounds complicated. What does it do?
Yeah, it's pretty state-of-the-art. Think of it as a more advanced way to guide the RL process, especially when you need the AI to figure out long chains of reasoning, like in complex medical scenarios.
How does it help?
It has a couple of neat tricks. One is called Clip Hire, which encourages the model to explore potentially better, even if initially uncertain, solutions. Helps it avoid getting stuck in a rut.
Okay, more exploration.
Right. And the other is dynamic sampling, which basically helps the training focus on the hard problems by filtering out prompts that are too easy or trivial for the model at its current stage. Makes the learning more efficient.
So better exploration and focusing on the tough stuff. Got it.
Now let's talk performance. How well do these models actually do? On a benchmark called HealthBench.
Which is?
It's an open source benchmark specifically designed for testing healthcare large language models. On that, the II Medical 8B model scored 40%.
Okay. Is 40% good? How does that compare?
Well, according to Intelligent Internet, that score is comparable to OpenAI's O1 reasoning model.
OpenAI's internal reasoning model.
Yes. And perhaps even more impressively, they say it's comparable to GPT 4.5, which they describe as OpenAI's largest and most advanced model to date.
Wow. An open source 8B model matching scores with potentially GPT 4.5 on a healthcare benchmark. That's huge, if accurate.
It's a very significant claim, yes. It really underlines the capability they've managed to pack into that smaller model size.
And they tested it on other benchmarks, too.
They did. They evaluated it on 10 leading medical benchmarks. Familiar names like MedMCQA, MedQA, PubMedQA, the standard tests in this field.
And the results there.
The takeaway message was that iMedical, particularly the 8B model, shows strong performance in the 7-8B class. Importantly, it apparently outperforms several larger models while being completely open source.
So again, punching above its weight class and being open about it, that really drives home the point that high-level capabilities are becoming much more widely available, not just locked behind proprietary APIs.
Exactly. That's the core theme here. Accessibility. And speaking of accessibility, they also make sure to point out how you can run these models.
Right, because having the code is one thing, but running it.
Precisely. They mentioned it can be run using platforms like VLLM and STLang.
What are those?
They're essentially specialized software libraries, open source themselves, designed to help run large AI models like these really efficiently, even on, non-supercomputer hardware.
So they make it easier for researchers or developers to actually download these AI medical models and get them working without needing massive infrastructure.
That's the idea, lowering the barrier to entry for people who want to experiment, build on this work, or integrate it into research tools.
Okay, so let's zoom out. We've covered the philosophy, the models, the training, the performance. What's the big picture here? What does this all really mean for you listening?
Well, I think this deep dive shows a really clear strategy from Intelligent Internet. They're not just trying to build capable, medical AI, they're deliberately doing it in the open.
Right, it's about putting these powerful tools out there, not keeping them locked up.
Exactly. Putting them into the hands of many, not just a select few. And doing it with, as we saw, a real stated emphasis on safety, on auditability.
And if we connect that back to the beginning, the great decoupling idea.
Yeah, you can see how these releases fit that narrative. They're concrete steps towards that goal of democratizing access to complex knowledge, specifically medical knowledge, and maybe even decision support down the line.
The focus on safety, on instruction following, on making the reasoning explainable, that all seems critical if these tools are ever going to be truly useful and trusted in healthcare.
Absolutely paramount. It shows, I think, a responsible way of trying to push the technology forward in a high-stakes field. But it definitely raises big questions, doesn't it? Like, what potential does this really unlock for healthcare in the future? And maybe more immediately, how will it change how you interact with medical information online or even through apps?
That's a great point. Let's leave our listeners with a final thought to chew on. Consider how this push for open source, safety-focused medical AI, how might that start to reshape things we take for granted?
Yeah, like medical education. Could students use these tools to learn differently?
Or clinical research? Could it accelerate discovery?
And what about personal health management? We talked about doctor-level medical reasoning potentially being in your pocket.
What new applications could emerge from that? But also, what new ethical challenges or considerations pop up when that kind of power becomes so widely accessible?
Definitely something to think about as this technology continues to evolve so rapidly.